All right, guys, welcome back. Today we are solving my favorite type of system. It's one with a quadratic equation and a linear equation. Now remember, the easiest way to solve any system ever is to just use graphing software. Graph them both in software and see where they intersect, and you'd be done. I don't have graphing software right now, so let's use algebra. So what I would like to do is use substitution. So let's do that. So if I look at equation number one, it's already set equal to y, which means it's already ready to substitute. So that means I'm going to plug in 3x plus 2 in for y into the second equation. So let's do that up here. So instead of a y, I'm going to put a 3x plus 2, which is equal to the rest of the second equation, x squared plus 2x. Awesome. Sweet. So if I look at that equation, it is basically a quadratic equation. It's just not in standard form. So let's put it in standard form. And we like to have quadratic equations equal to 0, putting it in standard form. So let's do that. So I'm going to move this 3x by subtraction and this positive 2 by subtraction to both sides. Two steps at once. Efficiency. Cancel, 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 cancel. 0 is equal to x squared. Then 2x minus 3x minus 1x, and then negative 2 has no like term, so 0 minus negative 2 is still negative 2. Cool. Here's a quadratic equation. And we know how to solve quadratic equations. The way to guarantee you can always solve it is use the quadratic formula. You can also factor, but today I'm going to solve it using the quadratic formula, just in case you get in a quadratic equation that isn't factorable. So, okay, we know that the coefficient of a would be 1, coefficient of b would be negative 1, and the coefficient of c would be negative 2. Awesome. Now to the quadratic formula. We know that x is equal to negative b, so negative b is a negative 1, plus minus the square root of negative 1 squared minus 4 times a, which is 1, times c, which is negative 2, all divided by 2 times 1. Let's keep simplifying. So we have a positive 1 plus minus square root of. Okay, be very, very, very careful. Watch your signs. This is a positive 1. A negative 4 times a 1 times a negative 2 is a positive 8. So it looks like 1 plus 8 is going to give us the square root of 9. All being divided by 2. Okay? So we know this is equal to now 1 plus or minus 3 divided by 2. Awesome. Now over on the left, let's break up into two equations. We have a top equation and a bottom equation. Let's do 1 plus 3 over 2. And here let's go 1 minus 3 over 2. So this looks like 4 over 2, which is 2. And this would be negative 2 over 2, which is negative 1. Great. We're done. Not really. Okay, so x equals 2. And x equals negative 1. Now remember, the solution to a system is the ordered pair, or ordered pairs where they intersect. So it looks like this has two intersection points. And that should make sense because one's a curve and one's a line. They can cross more than once. In this case, they're crossing twice. Okay, so let's find their y coordinates. So we know one of the coordinates is 2 comma y, and this one's going to be negative 1 comma their y coordinate. How do you find y? Easy. Plug into one of your equations. Doesn't matter which one. I like to do the easy work. So it looks like I'll plug into the top equation, y equals 3x plus 2. So let's plug in our x into that equation. So I have y equals 3 times 2 plus 2. So that would be 6 plus 2, which gives us 8. So when x is 2, y is 8. And this one, y equals 3 times negative 1 plus 2, which would be negative 3 plus 2, which is negative 1. So our two solutions are found at 2 comma 8 and negative 1, negative 1. And we are done.